All right, so look, you guys, this is actually simple, but for some reason students make it complicated. I don't know why. Maybe because they're half asleep when I go through it. I don't know, but it's really not hard, so don't make it hard, okay? Okay, so just know that this is basically the first part of what we're doing today, that some functions are formed by integrating some other function, starting at a constant a and going to the variable x. So for example, some function g of x might be defined like this. Just accept it. Don't think too much about it. Just know that to get the function g, you have to integrate f from a to x, okay? Simple as that. Now, in those types of problems, it's very important to remember that this part of it right here is what? Is just what? The what? The area between f and the x-axis from what? Starting at a and ending at what? X. Is that clear? Yes? So, whatever I put here is going to go there. Does that make sense? Because that's x, right? And the upper limit is x, right? Got it? Okay, so here's an example. And again, I typed it up. But it doesn't mean you can go to sleep. It's so you can pay attention and not miss anything. Ready? Okay, so again, suppose g of x is defined to be the antiderivative of f going from 0 to x. Okay, again, notice how those are the same, aren't they? Yes, so now on top of that, I gave you a graph of f. Okay, so with that in mind, if I ask you to find the value of g of 1, what are you going to do? You're going to put a what? What are you going to do with the 1, guys? You're going to put the 1 there and the 1 there to get g of 1, right? Everybody with me on that? Okay. All right, so with that in mind now, thanks. It now boils down to evaluating that integral to find g of 1. So, and again, that's the area between the graph of f and the x-axis from 0 to 1. Everybody agree? And so I shaded the region that you need to find right there. Everybody agree that's the area between f and the x-axis from 0 to 1, isn't it? Yes? And by the way, it just so happens to be what shape? A triangle. So to find that area, I can just use geometry, right? And do 1/2 base times height. So what is it? 1/2 1 times what? What? 2? Which is 1. And so there you go. So then g of 1 equals what? 1. Everybody with me on that? Because the area under f from 0 to 1 was 1. So that's the value of g of 1. Man. Thanks. All right, so if I ask you to find g of 3, what are you going to do? Well, you're going to take the given formula and you're going to replace x with what? You're going to replace x with what, guys? Come on. Show me you're awake. You're going to replace x with what? 3. So to find g of 3, you're going to put a 3 here and a 3 there to get g of 3. Then you have to evaluate that integral, which is just the area between f and the x-axis from 0 to 3. Everybody agree? And so you can shade it. What's it going to look like? Sam, what's it going to look like? A trapezoid. Good. Everybody agree this is the area I got to find right here? Yes? So it's up to you how you want to find that. You can split it up into a rectangle and two triangles, or you can just use the formula for the area of a trapezoid from geometry, however you want to do it. I'm just going to do the formula from geometry. So isn't it 1/2 the sum of the bases where the bases are parallel? So what's this bottom base, guys? 3. What's the top base? 1. And then what's the perpendicular height between the bases? 2. And so what does this equal, guys? 4. Any questions on that, guys? Are we good? Okay. All right, now, g of 5, to find g of 5, again, I just stick the 5 there and the 5 there. So to find g of 5 now, it boils down to finding the area between f and the x-axis from 0 to 5. And so here's 0, isn't it? And here's 5 over here, isn't it? So wouldn't you have to take this area and subtract this area? Why do I have to subtract this area? Why? Because it's below the x-axis. You can kind of think of it as negative area, so to speak, even though there's no such thing as negative area. So basically it boils down to find that. You find that area minus that area. So I'm not going to go through it. You see what I did. You get what? 2? Any questions on that? All right, now. All right, so you can see what's happening, you guys. Let me back up a minute. Ready? Since G is defined to be the area between f and the x-axis starting at 0 and ending at x, I want to now know where does G have its absolute max. Are you ready to talk about it? All right, so let's look at it. So I'm going to start at 0, and I'm going to keep adding area, aren't I? So isn't G going to keep increasing as I go left to right? Isn't it? As soon as I hit here, G is going to start to what? Decrease, because now you're subtracting area, aren't you? So where does G attain its absolute max? In other words, absolute greatest value. At what? At 3. Everybody agree right there? Because after that, you start subtracting area? Yes? So at x equals 3. Does that make sense? Yes or no? Okay. And by the way, this type of problem has been probably on every free response question or every free response test for the last 7 or 8 years. You're going to always see one of these. It might not be a nice geometric shape, but it's the same concept. Is that clear? Okay. Okay. Okay, let's start with this again. Okay, suppose G is the antiderivative of some other function starting at a and ending at x. Now, instead of the upper limit being a variable, it is actually sometimes going to be a function. Okay? So, notice what I did. In the first example, that was x. Now it's what? Now it's what? X cubed. Okay? All right, now, you guys watch this, because again, this is not very hard, but for some reason students get this wrong. I don't know why. Okay? You got to really focus, and once you see it, it's really not that bad. Okay. Now I want you to understand that I'm giving you this, and I want you to find that. Okay? I can't emphasize that enough. Otherwise, you're going to get everything all mixed up. Okay, so if I'm giving you the fact that g of x is that, and I want to find g prime, well then basically there's a couple ways to do it. Okay, I'm going to do it a long way, and then we're going to discover a shortcut. Are you ready? Okay, so the long way to do it would be to first find this antiderivative, and after that we'll worry about taking the derivative to get g prime. So, what is the antiderivative of cosine, guys? What is it? What's the antiderivative of cosine? Sine. And then I copied the limits, and then what's standard procedure from there? You stick in the what? Upper limit and subtract your g when you stick in the lower limit. Are you with me on that? Yes? And by the way, this is some number, isn't it? This is a number, right? Isn't sine of 5 some number? It's not 5 degrees, it's sine of 5 radians, but it really doesn't matter. It's a number, isn't it? Okay. All right, so once I get down to there, everybody agree I now have g of x? So once I have g of x written in a simpler way, can I easily take the derivative of that? Can I? You guys are not watching, and that's what's going to make you get lost. Watch. So to take the derivative of that, how do I take the derivative of that? Don't I have to use the chain rule? Yes? So I took the derivative of the outside, which is cosine, put the inside back in the way it was, and then multiply all that by the derivative of the inside, which is what? 3x squared. And then minus, what's the derivative of sine of 5, guys? 0. Because the derivative of a constant is 0. Are you following me on this? Okay? And so, then basically end up with just this then, yes? All right. So that's the long way. This is the long way to find the value, to find the function g prime of x, right? Does anybody see a shortcut that can take me from here to here? Anyone see a shortcut? Anybody see a shortcut? That I could skip all these in-between steps. Anyone see a shortcut? Go ahead. Yes.
You take like the derivative of the upper limit.
Okay. And you put it in front, right? And what else? In.
The function cosine.
Say that again.
Like the function cosine of this period.
Yeah.
The upper limit.
Yeah, carry down the upper limit and stick it inside the function here, right, in place of the variable. And then multiply by the derivative of the upper limit on the outside, yes? Everybody agree that's a shortcut then? That if I give you g of x in that type of form, it turns into that by exactly what you just saw. You take the upper limit, stick it into the function here, right? And then you multiply all that by the derivative of the upper limit, yes? Okay, by the way, did we, in the end, did the 5 matter? Did the 5 matter? No. What if the 5 was a 2? Well, then I would end up with what? Sine of 2 right there, but what's the derivative of sine of 2? 0. What if it was a 0? I would have had sine of 0. What's the derivative of sine of 0? 0. So does it really matter what the lower limit is? No. As long as it's a number, it doesn't matter. Everybody agree? Yes? Agreed. Okay. So there you go. So that's the shortcut then. Okay. Actually, the shortcut, right, that Kevin just pointed out for us has a name. It's called the first fundamental theorem of calculus. Okay. Again, some textbooks call it the second fundamental theorem of calculus, but it really doesn't matter. Just know that it's one of the fundamental theorems of calculus. Got it? And what is it? It's just a what? It's just a what? Shortcut to what? What's it a shortcut for? Well, this is what it's a shortcut for. To take the derivative of an integral that goes from a what? Constant to a function. Isn't that what that is here? Basically, I'm asking you to take the derivative of an integral that goes from a constant to a function. Isn't this when we're going to use the shortcut? Okay? And so what is the shortcut? You put the upper limit into the function and then multiply this by the derivative of the upper limit. Okay? And again, here's just another way of writing it. What does this mean? This means you're taking the derivative of an integral that goes from a constant to a function. So what's the shortcut? Well, you stick that into there and then multiply by the derivative of the upper limit. Okay? Is that very hard? Is it? I mean, is it? You just got to know when to use it and then how to use it. How to use it is easy. You just got to make sure you're clear on when you use it. When do I use this shortcut? I'm going to say it over and over and over. When do I use this shortcut? When you're taking the what? The derivative of an integral from a constant to a function. That's the only time. Okay. All right, so look what I'm giving you in example A. I'm saying g of x equals this, and I'm asking you to find the derivative of that. So is this a situation where we're going to use the fundamental theorem of calculus shortcut? Yes or no? Is it or not? Yes, it is. And by the way, notice that basically what I did is I took the derivative of that by writing that, and then I'm going to take the derivative of the right side by writing d over dx. Everybody understand that d over dx just means I'm taking the derivative with respect to x, right? And so what's the shortcut? To take the derivative of this integral that happens to go from a constant to a function, the shortcut is to put this into here, which I did right there, and then also multiply all that by the derivative of the upper limit. What's the derivative of the upper limit, guys? 2. And by the way, that equals this, doesn't it? And then when you simplify that, you get this, right? Good? Any questions? All right, why don't you try this one? Go. Try B. And compare your answers with your group members, please. Is this bringing back memories for you?
Yeah.
Yeah. Sorry. Can you see that? Can you see that? Can you see it? Okay. The upper limit's x squared if you can't tell. And the function's t cubed plus square root of t. I know you're not using it, but can you put that away for me? At least I hope you're not using it. Okay, guys, it's only like one step and then some simplifying, so we should be done. All right, so how about Danny? Okay, so the fact that I'm asking you to take the derivative of this thing, and it happens to be an integral that goes from a constant to a function, shouldn't I use my shortcut? Which is what?
d dx.
Okay.
Oh, yeah, from x is d dx.
Okay, that just means you're taking the derivative, right?
From negative 4 to x squared.
Okay.
T cubed plus square root of t dt.
Okay. All right, so what's the shortcut then to take the derivative of this integral that goes from a constant to a function? What's the shortcut?
Take the derivative in the
Up.
top limit.
Okay, which is what?
2x.
2x. And then what?
Move the top limit into the inside function.
Into the function. So hold on a second. So like that, right? And then what do I end up with?
2x to the 7 plus 2x squared.
Oh, I see what you did. And then you distributed it?
Yep.
Okay, yeah. You can distribute or just leave it like that. Doesn't matter. Okay, so if you want, you could distribute, right? Any questions on that? It's not bad, is it? Easy. Did I tell you it was easy? Okay. All right, now, this is a similar situation, but there's a problem here. Takuo, what's the problem on this one? Do you have your notes? Can you see it? Hold on, that's okay. You can't see it. It's too hard to read. Allie, can you read? What's the problem with this one? Yeah, it doesn't go from a constant to a function. It's the other way around. Well, don't we have a way of fixing that, guys? Yeah, how? How? Putting a what? Negative out front, and then you're allowed to switch the limits, right? Okay, so that's what I'm going to do. I'm just going to switch the limits. I can do that anytime I want to, as long as I put a negative on the outside, right? Okay, now does this fit the form? Does it? Yes, it does. And because, again, remember, the only time you use the shortcut is when you're taking the what? The derivative of that. And I guess that's where students make their mistake. They use the shortcut on there when they don't even ask you to take the derivative. Well, if they don't ask you to take the derivative, then you wouldn't do any such thing, would you? No. Okay, so the fact that I am, though, asking you to find the derivative means you just leave that negative out front and take the derivative of that, right? And so, again, don't you take the derivative of the upper limit, which is 3x squared, and then multiply by what you get when you stick the upper limit into the function, right? Is that it? Everybody agree? Okay. Not bad, is it? Told you it wasn't bad. Okay, next page. Okay. All right, before we do the next example, I'm going to review some things about the relationship between f and f prime. Okay, you already know all this. This is not anything new. This is review. Okay, I'm just going to quickly go through them. Just kind of refresh your memory on this. You know all this already. When f prime is positive, in other words, graphically that would be above the x-axis, f would be what? Increasing. When f prime is negative, which means graphically if f prime is ever below the x-axis, I'm sorry, f prime I should say, if f prime is ever below the x-axis or negative, the graph of f is decreasing, right? Okay, number 3, when f prime changes from positive to negative, f will change from increasing to decreasing, causing f to have a hill or local max. Remember all that? Heads up, please. Are you with me on this? Okay, when f prime changes from negative to positive, what happens with f, guys? It changes from what? Decreasing, increasing, therefore f has a valley or a local what? Min. When f prime is increasing, f will be what? Concave up. When f prime is decreasing, f will be concave down. You already know all this. Number 7, f will have an inflection point then when what? F changes what? Concavity, either from down to up or up to down. Therefore, 7 and 8 kind of go together. Therefore, we can say that f has an inflection point whenever f prime changes from what? Increasing to decreasing or vice versa. Yes? Again, this is nothing new. Okay, now, let's do an example. All right, again, this is a typical AP question right here. Okay, I can show you lots of old AP tests that have questions just like this, with an A, B, C, and a D, and so on. Okay? All right, suppose G is given to be this. Okay, where F is the graph shown below. So again, this is a graph of F. Is everybody clear on that? Good? Okay. So if that's a graph of F, okay, what's the first thing I'm going to do? Well, it says to find G prime. So how do I find the derivative of that, guys? How? Yeah, don't I substitute this into there and you get what? F of x, and then multiply by the derivative of the upper limit, which is what? 1. So don't you just get f of x? Yes or no? Okay. So what I'm saying then is G prime is the same as what? F. So not only is this a graph of f, I can also label it as a graph of what? G prime if I want. So again, you guys, so what you're looking at is not only a graph of f, but you're also looking at a graph of G prime, aren't you? Agreed? Okay. All right, so now that you're looking at a graph of G prime as well here, I should be able to answer all kinds of questions about G. So, looking at that graph of G prime right there, guys, where does G have a relative max? Well, G will have a relative max or a hill whenever G prime changes from what again? Positive to negative. And so where's that? Where does G prime change from positive to negative, guys? Where? Where? At 1. Right there, yes? At x equals 1, since G prime changes from positive to negative, causing G to do what? Causing G to what? To change from what? From what? Yeah, increasing to decreasing. Very good. Everybody agree? I mean, if this were the AP test, you would have to say all of that, okay? Because it asks you to justify your answer. It says why. Okay, so you'd say G has a relative max or a hill at x equals 1, since G prime changes from positive to negative, causing G to change from increasing to decreasing. And again, but before you can talk about G prime, you have to establish this first, right? You have to establish the fact that not only is that a graph of f, but it's also a graph of G prime. So now you can start talking about the graph of G prime. Any questions on that? Are we good? Yes? All right, next one. Where does x have a relative min or a valley? And so I'll call on somebody. How about, I don't know, Adam G. What do you think? Where does G have a relative min or a valley? Whenever G prime changes from what? No, whenever G changes from decreasing to increasing. But when does G change from decreasing to increasing? Whenever G prime does what? Changes from negative to positive. Very good. And so looking at the graph of g prime, where does g prime change from negative to positive? When x equals 3. Okay, good. And so you would say at x equals 3, since g prime changes from negative to positive, causing what? Causing g to change from what? Say that again. From? Good. Okay? So again, at x equals 3, since g prime changes from negative to positive, causing g to change from decreasing to increasing. That's what causes the valley in the graph of g, doesn't it? Okay? Okay. I want to now know, where does g have a inflection point, if at all? Well, g has an inflection point whenever g prime changes from increasing to decreasing or vice versa, right? And so wouldn't that be here and here? Because right there, g prime changes from decreasing to increasing, and right here, g prime changes from increasing to decreasing. Yes? So you'd say at x equals 2, since g prime changes from decreasing to increasing, and also at what? X equals what, guys? 6. Since what? G prime changes from what? Changes from what, guys? Increasing to decreasing. Okay. Any questions? You guys are pretty quiet today. Any questions on what I'm doing? I mean, most of this is review. I'm just tying what you already know into something that, you know, just another step or two. Right? Got it? All right, now, we need to find g of 0, right? Okay, so all right, so look, if I want to find g of 0, and this is g of x, look at that. How would I find g of 0? I'd have to put a 0 there and a 0 there, wouldn't I? What do I get when I put a 0 there and a 0 there? When the upper and lower limit are the same, what's the value of the integral? What is it, guys? You should know all this. 0. So isn't g of 0, 0, guys? Okay. I should have spread these out. Let's do that. Let's put g of 1 over here. Let's put g of 3 over here. And let's put g of 6 over here. I just don't want to cram them together. Okay. All right, so what's g of 1 now, guys? Well, don't I put a 1 in here now and a 1 in here to get g of 1? And so doesn't g of 1 become the area between f and the x-axis from 0 to 1, doesn't it? And so what is it, guys? Wouldn't that be this area here? What is it? What is it? What is it, guys? What's the area of that little triangle? 1/2? Yes? Would you agree it's a half? Okay, let's find g of 2 now. G of 2 would be the antiderivative of f from 0 to 2, wouldn't it? And that would be just the area between f and the x-axis from 0 to 2, which would be this area minus this area, isn't it? What's that area minus that area, guys? What is it? 0. What, do you see what I'm doing here? Yes? Okay, you guys, you got to bring your notes. This stuff is too hard to see. I mean, you guys are just making it harder on yourself by not bringing your notes. I gave you notes last time, but I can't do it every time. You guys got to be responsible. Okay, let's look at g of 3 now. G of 3 would be the antiderivative of f from 0 to 3, right? In other words, the area between 0 and 3, right? I'm sorry. Yeah, the area between f and the x-axis from 0 to 3. So wouldn't that be all this area minus that area minus this additional little triangle? So what would that be? Basically, it would be 0 minus what? A half, which is negative 1/2, isn't it? You getting this? This is not hard, guys. Don't make it hard. It's not. All right, now what? This is what? Just put a 5 in there. So now you're talking about the area between f and the x-axis from 0 all the way to 5 now. And so, well, basically that and that is 0 minus, that's a half. 1, 2, 3, 4, 5. So basically, don't I need to add this area now in here to my previous answer? Yes? So what is it? It's a negative a half plus what? What is it? A negative a half plus what? 2, which equals what? 1.5? Yes? Yes or no? Okay. And then finally, g of 6 would be what? Well, again, all of that area, which is a half, and then add what? Don't you have to add this additional 2.5 square units? So what's 1.5 plus 2.5? What is it? Come on, guys. 4. Okay, now, why do you think I'm only asking you to estimate g of 7? Why? Well, to find g of 7, don't I need to add this area, which is not a nice geometric shape, but what is it? About what? It's about what? It's about what? How many square units are there? You can just look at it and count the squares. It's about what? 2 or so? But you agree that's about 2 more? Yes? So 2 added to your previous value of 4 gives you about what? 6. So about 6. Okay. All right, so now it says sketch a graph of sketch a graph of g, I should say. All right, so here's what I'm going to do. I'm going to plot all the points that I know and then just kind of go from there. Are you ready? All right, so what do I know? G of 0 is what? 0. So put a point here, yes? Okay. Now what? What's G of 1? What's G of 1? Come on, guys. I already plotted that point, 0, 0. Now I'm plotting the point what? Remember, this is G of x, right? So what is? I just plot the point 1 comma half, which is right about there. And then I plot the point what? 2 comma 0. Then I plot the point 3 comma what? Negative a half. Then I plot the point 5 comma 1.5. It's right about here. Then I plot the point 6 comma what? 4. It's right about here, right? And then I can plot 7 comma 6 approximately, right? Yes? Okay. All right, now. And again, make sure you see that there's a 0 here and a 0 here, right? Okay. Now I'm going to play connect the dots, but I'm not going to randomly play connect the dots. I'm going to use everything I know up here to help me connect the dots with a little bit more detail. Are you ready? Yes? Here it goes. I'm going to go back to here for a minute and know that this is a graph of what? This is a graph of what? G prime. So if that's a graph of G prime, look at what's happening between 0 and 1 with G prime. Between 0 and 1, G prime is what? Between 0 and 1, G prime is what, guys? It's what? Positive, because it's above the x-axis, but it's decreasing from left to right, isn't it? So if G prime is positive and decreasing, what can you tell me about G? If G prime is positive and decreasing, what can you tell me about G? G is what? More than that. G prime is positive and decreasing. What can you tell me about G? It's increasing and concave down. So I'm going to connect these dots with a graph that's increasing and concave down. So kind of like that. Yes? See how that's increasing and concave down? Okay, how about between 1 and 2? Looking at the graph of G prime, what can you tell me between 1 and 2 here? G prime is what? Negative, right? Because it's below the x-axis, and it's also what? Decreasing. So what can you say about G on that interval? G is what? Decreasing and concave down. So I'm going to connect these 2 points with a graph that's decreasing and concave down, kind of like that. Yes? Okay, how about between 2 and 3? G prime is what? Negative and increasing. Therefore, G will be what? Decreasing and concave up. So I'm going to connect these 2 points with a graph that's decreasing and concave up, kind of like that. Got it? And then how about between 3 and 5? Between 3 and 5, G prime is positive and increasing. Therefore, G is what? Increasing and concave up. So I got to connect these 2 dots with a graph that's increasing and concave up, kind of like that. Yes? Isn't that increasing and concave up? Okay, how about between, I'm losing my track here. Let's see, 1, 2, 3, 4, 5. Okay, so how about between 5 and 6 here, guys? How about between 5 and 6? G prime is still what? Positive and increasing. Therefore, G is what? Increasing and concave up. So I got to continue to connect those with a graph that's increasing and concave up. It's kind of hard to do, but it's like that. Yes? And then how about between 6 and 7, guys? Now G prime is what? Positive and decreasing. Therefore, G is what? Increasing and concave down, kind of like that. Yes? Okay? With me? And then how about, well, yeah, that's good, right? Because that's as far as I can go, guys. Okay? We good? All right, last page. All right, we're going to do this together. Okay. I gave you G to be the antiderivative of f from -3 to x. Now, notice, this is a graph of f, but all these questions are about what? G. So I have to establish some relationship between the two before I can start answering these questions. Do you agree with that? Okay. Any suggestions on what I can do there? I can do what to both sides of that equation? Take the what? Derivative. And so if I take the derivative of both sides, so I'm just going to put a d over dx out front to indicate I'm taking the derivative. Okay, so now look what you're doing. You're taking the derivative of an integral that goes from a constant to a function. So isn't there a shortcut for that? Don't I put that into here? Giving you what? Giving you what? F of what? X. And then don't I multiply that by the derivative of the upper limit? What's the derivative of the upper limit? 1. And so what do I get out of that? I get the fact that G prime is equal to what? F, don't I? Isn't that what I get out of that? Isn't it? And so not only is this a graph of F, it's also a graph of what? G prime as well. So now we're good to go because I'm now looking at a graph of G prime as well. And it's pretty easy to look at a graph of G prime and say a whole bunch of things about G like we just did on the last example. You with me? You see where I'm at? Okay? All right, so here we go. You're going to help me. I'm going to call on you. There's probably enough questions here for half the class, so be awake. Ready? Okay, John, you can start us out here. Looking at a graph of G prime, I want to know on what intervals is G increasing and why. So what is it? What do you think? Okay, yeah, by the way, let me label these. Okay, so you said -3 to 0? Okay, good. And why? Since what? Okay, good. Everybody agree with John? I do. Are we good? Yes? So wherever G prime is positive, meaning above the x-axis, you can say G is increasing. Okay? All right. Next one. Who's it going to be? How about Gloria? You can do this one. Okay, from 0 to what? 3 since what? Say that again? Well, wait. G. You got to talk about G prime. Since G prime is what? Is negative. Okay, good. Okay, yeah, the graph of G prime tells us about G, right? Okay, Lauren, you can do the next one. Okay, be careful here. This is kind of like 2 steps in one, isn't it? G will have a relative max, which is a hill, whenever G goes from increasing to decreasing. When will G go from increasing to decreasing? When G prime does what? Goes from what? Positive to negative. Does that ever happen here? At 0. Good. And again, your reasoning would be, since G prime changes from positive to negative, causing G to change from what? Increasing to decreasing, and that's what creates a hill? Yes? Again, there's not a whole lot of memorizing there, guys. It should make sense to you by now. Does it? Okay. All right. Max, you can do the next one. Where does G have a relative min? Never. And your reasoning would be because G prime never changes from what?
Negative to positive.
That's right. Okay? Yeah, in order for G to have a value or relative min, we would have needed G prime to change from negative to positive. In other words, from below the x-axis to above. Does it? Does G prime ever go from below the x-axis to above? Does it? No, it does not. Okay. All right, next. How about parth? You can do this one. G will be concave up whenever what? G prime is what? Say that again? Increase. Increase. Okay. So looking at the graph of G prime, is G prime ever increasing? Yeah. From where to where? Yep. And 2 to 3. Very good. Okay. All right. So you would say from -3 to -1 and 2 to 3, right? Since, and all you got to do is say since G prime is increasing. Yes? Very good. Okay. All right, Sandhya, you can do the next one. On what intervals is G concave down? -1 to 2. Okay, good. And why? That's right. Okay, almost done, guys. Couple more. Hang in there with me. All right, how about Anthony? You can do the next one. Okay, hold on. You're looking for where G has an inflection point. Where did you say? -1 and 2. That's right. And so let's do one at a time. So let's say at -1, since what? Okay, remember, never say it. They're not going to know what you're talking about. You got to be specific. Never say it. Since what?
graph
Of what?
here,
G prime changes from what? Okay, good. Yeah, you guys never say it. I find myself saying it sometimes too, but you got to be very careful to be specific. Okay, don't use it in your explanations. Be specific. Okay, so we're talking about G prime changing from increasing to decreasing, yes? And then where else did you say, Anthony? Also at what? Since what? G prime does what? Okay, good. Okay, two more. How about Adam K?
x equals 0.
Okay, yeah, okay. So again, remember, this is an absolute max, right? Not a local, right? And so, go ahead. What were you going to say at what?
At x equals 0.
That goes 0. Why? Because from -3 to 0, G does what?
It changes from increasing to decreasing.
Yeah, remember, don't say it though.
G prime changes from increasing to decreasing.
Wait, be careful here. Let's see. You are right that it is at 0, but you got to be careful on your reasoning. So I just want to be, actually, I want to see the best way to explain this. There's a couple different ways you can explain it. The bottom line is, you guys, G of x is defined to be the area between f and the x-axis starting at -3 and going to x. So as I start at -3 and I go left, aren't I adding area? Isn't G increasing, right, to there? And then after that, you start subtracting area, right? And so therefore, G starts to decrease, right? Okay. All right. And so here's how I would explain it. I would draw a little graph. So you could say at x equals 0. And you could say since G increases by area 1, then decreases by area 2. Right? Yes? So if G goes up from -3 to 0, and then decreases from 0 to what, 3? Doesn't that prove that the absolute maximum on G, yes, would occur at x equals 0? Agreed? Okay. All right. Last one. How about Andrew? Where does G attain its absolute minimum? Yes. Very good. Again, okay, so here's the reasoning, guys. Since area 2 is smaller than area 1, isn't it? Isn't area 2 clearly smaller than area 1? Isn't it? Isn't this area here smaller than area 1? So what that means is G is going to increase in here by more than it decreases here. Isn't it? So wasn't G smaller at the beginning then, at -3 then, wasn't it? What if area 2 was bigger than area 1? Then where would G have its absolute minimum at? At the end, which would have been at what? X equals +3. Does everybody see what I'm looking at here? Yes? Okay. Since area 2 is greater or less than area 1, and G increases by area 1, then decreases by area 2. So, if this were the AP test, you would have to say all of that, okay? You have to say why, specifically. So again, G increases by area 1, then decreases by area 2, but since area 2 is smaller than area 1, it's going to be bigger at the beginning, isn't it? It didn't go down enough at the end to be smaller than G was at the beginning. Do you understand what I'm looking at here? Yes? Because remember, G, according to this relationship, you can find G by finding the area under F starting at -3 and stopping at wherever X is. You understand that? Yes?
When can we tell just from looking at it?
You will. You'll be able to tell. And a lot of times, those will be nice geometric shapes where you can actually find the area and prove it. But if you can't, then you just got to kind of eyeball it and say, clearly area 2 is smaller than area 1. Got it? That's it, guys. I mean, I'm done. So that's it. You got some book work. You can take a break till about 8:20 or so, and then you got about a half hour to work on this. Again, you should be able to get a lot of it done, if not most of it. Okay? You okay, Danny? You all right? Sure? Can you guys read my sloppy writing up here or not? Is it okay?